Welcome everyone, and thank you for joining today's webcast. My name is Shivani Hegde and I'm going to be a moderator today. So this is the third episode of a series which will introduce you to the PLE across the development life cycle with pure variants and also its integrations to various engineering tools. So today's topic is PLE and model-based system engineering. And I would like to introduce our presenter, that is Robert Hellebrand. Robert Hellebrand is a senior field application engineer at Pure Systems. So he helps the customers with their challenges in efficiently reusing engineering assets and also making the transition from project-oriented development towards the feature model-based product line engineering with pure variants. So yeah, today we will cover the topic PLE and model-based system engineering, that is managing variability in system and software architecture, and also experience how a typical PLE workflow is structured. And in the following episode, which is the last one of the series, we will cover how to manage variability in code by using pure variants. So also you can find an overview of all the upcoming webcasts on our website. The link has been displayed on the slide, and also these webcasts will be recorded and will be uploaded to our Pure Systems YouTube channel. So in case you have any questions, you all can make use of this chat system that we have and post it anytime. And also this only the webcast team can see your questions that you all have posted. And what we will do is we will collect all these questions and ask it at the end of the webcast during the Q&A session. And in case of any open questions left after the Q&A sessions, we will contact you after the webcast in order to follow up. So now I would like to hand it over to Robert.
Yeah, thank you, Shivani. And yeah, I will jump right into the topic with first explaining the general concept of product line engineering with pure variants. And yeah, then we will go on and see how this concept is applied to model-based systems engineering assets based on our in-tool integration with Enterprise Architect. So the pure variants or PLE approach follows two different concepts. First of all, we follow a 150% approach, meaning instead of managing your different engineering assets like requirements, test cases, code, and also architecture in parallel for multiple product variants, you work with supersets or 150% of engineering assets. So you will have 150% architecture that holds some elements that will be part of all of the different variants or specific architecture, but also some elements that will only be part of certain of these variants. And the variable part of your 150% architecture, that is connected to your features in a feature model. So that's the second concept pure variants makes use of, the concept of feature modeling. In a feature model, you basically hold the information on a more abstract level about what can vary between your product variants. Like a good feature in a feature model could be a functionality that's active in one variant but doesn't play a role in another variant. Or also the different markets you are developing your variants for could be modeled as features in a feature model, as the decision for a specific market has an impact on your solution assets and how they should look like. So maybe you have to follow different regulations and standards for different markets. And in the end, also the knowledge about interdependencies between those features is modeled explicitly into those feature models. So you can say your expert knowledge that is usually distributed across many heads, across many experts, is now made persistent and formalized in the feature model. And this knowledge is mapped to your to your solution assets, to your supersets of engineering assets, so also to your superset architecture. This in the end allows you to configure your variants based on the feature model, so on a much higher level of abstraction than it would be the case if you had to look at the single actual solution assets of the different variants each time. And this is done in a so-called variant description model. So while in the feature model you model which features exist across your whole product line, in the variant description model you see those features that you earlier defined here in the variant description model, and you now for a single variant define which of those features go into this specific variant by selecting the features. And after each of those selections you make here in the variant description model, you get immediate feedback. So your variants will tell you which other features will be needed in combination, which others are now not possible to select as well as they would be, or as they are mutually exclusive. So all the expert knowledge that you put into the feature model about interdependencies is regarded during the variant configuration in your variant description model. And you know at any point in time which other decisions you have to make to get to a variant that is valid. And in the end, you then can use this input to generate out of the 150% variant engineering assets, the variant specific ones. So meaning you can also generate out of your 150% enterprise architect or system architecture and software architecture, the variant specific ones. And we will now have a closer look at how this works based on an example. So we will see this based on a fictional external car light product line. And we will start on the feature modeling side. So the feature model is built up and maintained in the Pure Variants Eclipse client, which is typically the place where so-called product line engineers take over this task of maintaining the feature models and also configuring the variant models. Other tasks like mapping your architecture to your feature model and also mapping other assets to your feature model, this is typically done by the roles that have the knowledge about that specific engineering assets. So the architects would actually create the mapping between the features and their 150% architecture from within the tool they are used to with help of in-tool integrations. So let's see what a product line engineer sees. So a product line engineer is working with the Pure Variants Eclipse client, and here, for example, he can or she can access the feature model, like we see one here. Feature models are always tree structured, so you can see we have on top the feature external car lights, and below it multiple other features. And you see each feature shows up with a name of the feature, and in front of that name you can see the symbol, this yellow circle with an F inside indicating that it is a feature, and in front of that you see another symbol that is indicating the variation type of that feature. So here you can see an exclamation mark. This indicates that this feature is mandatory, so it will be part of all variants automatically. It's always needed. The features below are maybe more interesting then. So they have a double-sided arrow in front of them, meaning they are alternative features. So alternative features are always mutually exclusive, meaning in each variant, if the parent feature is part of the variant, you have to decide for exactly one of the given alternatives here. So each variant will either use xenon or halogen to implement low beam. Then we have multiple features with question marks in front of them here, like fog light, daytime running light, and driver assistance. They are optional, meaning in each variant you can decide whether you want to include one, two, or all of these optional features into the variant. It's the most flexible variation type. If you decide to include the feature driver assistance, for example, then you have additional features that you can decide to include or not. So here you see these features have a blue cross in front of them, meaning here they are OR features. So OR features they work this way, that if the parent feature is part of the variant, then you have to select at least one of the OR features below, but you can also select more than one OR feature. So it's 1 to n that you can include in the variant. Beside the hierarchy and the variation types, we also have the concept of so-called relations in our feature model. So here, below static cornering lights, for example, you can see a requires relation that goes from static cornering lights to the feature fog lights. That's in a different part of the feature tree. So these relations allow you to draw interdependencies between features across the tree and even across feature models, if in case you use multiple feature models. And these relations are always typed. So in this case, the type is requires, meaning if I select static cornering lights, then I definitely also require the feature fog lights that's otherwise optional. To give you an example for a relation that spans across feature trees, we have here the feature hazard warning that I'm just selecting now. And if I select such a feature, then the relations view on the right hand in this tool always shows me which other features and which other solutions assets are connected to that currently selected feature. And you can see there's another requires relation from the feature Sweden that points at the feature hazard warning. And this feature Sweden is actually located in a different feature model, in the feature model regions. You also see that requirements, code, and test cases are connected to this feature hazard warning. So if we now want to navigate through these relations, we can use the relations view and just double click on the feature Sweden in the relations view to navigate directly to this feature Sweden. You see now the menu switched to the regions feature model and Sweden was highlighted that has this requires relation to hazard warning. And the relations view now, of course, is also updated and shows me which features Sweden is connected to, and this feature hazard warning again. So now we want to make use of these two feature models to configure a new variant. So in this example, we will configure a new variant for the Swedish market that we want to call Baselight Sweden. Let's see how this is done. First, we go to the left side into the variant projects view. And here we navigate to our configuration space. You see it here. Below this configuration space, you see there are already some existing variant description models, and we are adding another one. About the configuration space itself, it's important to note for the VDMs, it works like on a folder, like a typical folder, but it's actually more. So in its properties, you define based on which of the feature models you want to configure these variants. So this configuration space is pointing at the functional features feature model that we just had a look at and at the regions feature model. And we see the impact of this immediately when we create a new variant. So let's do this. Via the context menu, I say I want to add a new variant model to this configuration space. A wizard pops up. Here I have to now enter a name for this variant. So I will just call it Baselight Sweden. And if I click on next, the wizard will ask me whether or not I want to make use of inheritance. So the concept of inheritance means that you can inherit feature selection from an already existing variant model. So for example, you can also here introduce only partially configured intermediate variant models that your actual variants or parts of your actual variants later on inherit some selections from. This has the advantage that you don't need to start configuring a variant from scratch, but you already inherit some of the selections and only have to take care of the open ones. Sometimes this is useful. So here we keep it simple and we will not use inheritance. We just start from scratch. So here you see we now are in the Baselight Sweden variant description model, and it looks quite similar to our feature models. But some things, of course, are also different. So for example, you see we here have now the features of both feature models, of the functional features and of the regions features feature model. And also in front of each feature, we now either have check marks or open boxes. So all the mandatory features, they have now check marks in front of them to indicate that they are definitely part of the variant, as they have to. And in front of all the other features, we now have these boxes to indicate that you now can decide whether or not to include those features into the variant. For some places of the variant model, you also will have or might have such error markers. They point you at places of the VDM where you have to make a decision in order to end up with a valid variant description model. And if you hover over those error markers, the tool will also give you a tooltip and tell you what's the reason here why you get this error marker. For example, here we saw that this error marker exists. So let's highlight this again. This error marker exists because there are open alternatives below mandatory features, and we have to decide whether we now want to either include one or the other alternative. So we can do this by just clicking at the error marker and following and making a decision here. Or we can just expand the feature model and click directly on the box. In each case, once we have selected such a feature, the model shows me that the other alternative is no longer selectable. As you remember, they are mutually exclusive. And such an evaluation also happens and works when we have relations in place. So for example, here you will see we want to select the Swedish market as a region. And you remember, Sweden requires to have hazard warning enabled. So you will see, due to this requires relation, pure variance will understand this, and the autoresolver will resolve this relation. And once I select Sweden, it will select hazard warning automatically for me. If I don't like this, I can also turn the autoresolver off. Then instead, I get another error marker informing me that I now would also need hazard warning, as Sweden requires that one. If you have the auto-resolving turned on, you can also see that selections you made on your own show up as check marks in a box, while selections done by the auto-resolver show up as a check mark. So you can always distinguish which decisions did you make and which were made automatically because of the rules that the knowledge that you placed into the feature model. But what does this mean now for our architecture? Well, if we already have a 150% architecture in place now, and we have already mapped it to our feature model, then at this point in time, after selecting the features, we are already ready to generate variant-specific architectures based on this selection. But initially, we have to establish this mapping. So let's have a look how this is done. So now we also switch roles. The mapping between the architecture and the feature models would typically be established by an architect who knows the architecture and knows which parts will be needed under which condition. And actually, this task happens right in the solution tool. So today we will have a look how this is done in Enterprise Architect. So here we have a 150% architecture, and we are looking at a class diagram of this architecture. And we now want to express that the class hazard warning is not part of all variants, but it's only needed if a certain feature, namely the feature hazard warning, has been selected. To do this, via the context menu, we can add a new constraint to this hazard warning class. And you now see our editor opens, a special editor from our integration that knows about all the features of your configuration space. And by starting typing a name of a feature, the list of available features is filtered down, and you can just click into this list and select the feature you were looking for. And this class will be restricted with this feature, meaning only if this feature has been selected, this class will be part of the variant-specific architecture. For other variants that don't have this feature selected, this class and all ingoing and outgoing transitions will be removed when we generate the variant-specific architecture out of this 150%. Also, the in-tool integration at all time gives you a view over the features of your feature model. So as an architect, you don't need to actually switch over to Eclipse. You have all this information available inside of your MBSE tool. So once you have connected your solution assets like your classes, state diagram elements, and others to your feature model, you can also trigger a preview from within Enterprise Architect to see how variant-specific architectures would look like. So here we can now, in the integration view, select a specific variant that we earlier specified in pure variants. You see which features are selected in this variant. And by clicking on a preview button, now all the elements of the architecture that are not needed are grayed out in the diagrams. You see this works across diagrams. And we now can quickly switch between variants also to see how the different variants are different from each other and where they are similar. This helps you to easily understand as an architect what's the impact of the rules you put here on your variable parts of the architecture. Also noteworthy to mention, every element in your architecture that you didn't map any feature to is always there. So the common parts of your architecture don't need to be mapped. So the preview is nice, but at a certain point you will sure also want to derive variant-specific architectures. So you want to instantiate a specific architecture for a specific variant. You can do this in two ways. You can either trigger this so-called transformation manually, like we will show here, or you can also fully automate this and run this headless via build script. But let's see how to trigger such a transformation. We have now a variant model opened, and we go into the transformation menu, and here we can decide what we want to transform, and we want to trigger an enterprise architect transformation here. So now Pure Variants is taking these feature selections along with our 150% architecture as an input and is generating a variant-specific output for you. Here we have specified that the output shall flow to this output folder, and we are now opening the currently generated variant-specific architecture, and you will see if I now open the diagrams of this architecture, all the elements that are not needed have been removed. So we end up with a clean architecture where all the variation points have been resolved. So that's basically how this 150% approach with feature modeling works. What are the advantages? I hope it was obvious, so that you now have a centralized place to add functionality or to make changes to your architecture. You don't have to maintain 20, 30, 40 architectures in parallel for your different variants. You can make amendments to your 150% architecture and then trigger a transformation to let these changes flow to your variant-specific architectures, to the ones that need it. So you have a way to automatically propagate changes to the variants that need such a change. Also, the same feature model that we now use to control variability in our architecture, we can also connect it to our 150% requirements, test cases, and code to ensure that based on the same feature selection, all of these different assets are generated based on the same knowledge about variability. So they are consistent to each other. You can get to a consistent reuse strategy this way. It also allows you to have a quick starting point for new variants. So imagine a new customer request comes in, or you want to start a new product variant. You start configuring it by selecting features. You generate the reusable assets that you can reuse for this variant. And then you can focus completely on maybe new functionality that you haven't had in your product line before and develop this instead of having to spend a lot of time scanning your existing assets and understanding what you can reuse in combination. Also, as you are making your interdependency knowledge persistent in the feature model, you also have a lower risk of knowledge, of know-how lost during a longer running product line. So after 10 years, some engineers might have switched roles or might have left company. The knowledge about interdependencies in this approach is still there and can be applied. So today we just had time to scratch the surface of capabilities that this approach offers, and Pure Variants has many more things to offer, like analysis views and reporting capabilities that help you to keep an overview of your product line and reusable assets. Advanced concepts like co-evolution, so parallel evolution of your variant-specific assets and your 150% assets, and keeping them updatable and letting changes flow back into your product line from the variants, as well as the topic of transforming in multiple steps instead of one step, so-called partial configurations. If you're interested in those advanced approaches, make sure to check out our other webinars that you can find on our YouTube channel. Also, feel free to contact us to get more information. And don't forget to register for our next webinar that will show you how to use this approach for source code. With that, I'm done. I say thank you for your patience and attention, and I hand over back to Shivani.
Thank you, Robert, and thank you all for your attention. So now we have some time left for questions. If you have any questions, please make use of the chat system. Yeah, so we have one question here. So that is there a way to add same restriction to multiple elements in the architecture?
Yeah, good question. And actually, the answer is yes. We only saw it briefly in today's demonstration. Uh, you can make use of constraint elements in Enterprise Architect and convert them to pure variance constraints. And there you can write your PV mapping rules into, and you can then use transitions to connect these constraints to multiple elements in your diagram. And then this constraint will affect all of those elements and even transitions. So you can also connect this directly to other transition to make this variable.
Okay, thank you. Um, yeah, so I believe there are no more questions left. I would like to close the session now. And thank you for watching and goodbye.